Who knows how RAG works? That's not a lot of people. So we'll quickly look into that. So we have basically two components in RAG, Retrieval Augmented Generation, and the two components are Retrieval and Generation. And the idea is the generation is the LLM part, where the LLM gives you an answer. And sometimes this works very well, and sometimes it doesn't, because either the data is too old, or the data is too specific, or it's private data, so an LLM cannot give you the right answer. A classic example would be you work in a big company, and you ask the LLM, what is my insurance policy? And a generic, general purpose trained LLM will have no idea what your specific insurance policy is. And that is where RAG is coming in. RAG, the idea is you ask a question, and rather than just answering the question with an LLM, you fetch some data, so you have some relevant data. You run that query against that data and fetch or retrieve what is relevant from documents, images, or audio. You add the answer that you retrieve here as context. You send the question plus that specific context to the LLM, and then the LLM generates you the answer out of that. So you provide your custom context to give you better answers. So for example, for your insurance policy, ideally you would find the right page which states what your insurance policy is. You give that context to the LLM, and then the LLM will say, whatever is your insurance policy. And for many other use cases where you can provide custom data or newer data or something that is just too specific to answer in general. That is the general idea of RAG. And the two main components are the retrieval to get that context and the generation to generate the output. And RAG is a very buzzwordy topic, or it's very hyped, and it comes up in many conversations. But it is a very useful pattern, and we'll see a bit more advanced ones or how this goes. The other thing that often is mentioned in this context is vector search. Who has heard of vector search? Who has used vector search? Okay, that's fewer. So the idea is classic search, and we can look at a very quick example afterwards. Classic search is keyword-based or lexical. You basically have a word, and you look up that word. The problem is, if you use the wrong word, like you use a synonym or it's slightly phrased differently, your search does not find what you mean. And the idea behind vector search is that you can have more the meaning embedded and search more on that meaning rather than the exact character match. The other side is that you can also search other formats. So for example, images or audio can also be turned into a vector representation and then be searchable. And when I say vector representation, basically each input of image, document, or audio is turned into an array of floating point numbers. It's just like vectors as we have seen them in school, and that represents some document. And then when you search, that is kind of like, so the left-hand side was, this is the data that you have. And each of these types of documents, or each document or image or audio is represented by this vector, which is this big array of floating point numbers normally. And when you search, your query also gets translated to this vector representation. And then you basically check this vector here, which one of these is the closest one, and that would be your match. So it's not just like lexical meaning and like word overlap, but how the meaning is kind of like related. And then the result is that you find, hopefully, the closest meaning and not just the lexical match. And while RAG doesn't require you to use vector search, it can be very helpful to just give you a broader net or better search results. So you could just do RAG with classic keyword search, but oftentimes you want to maybe do vector search or hybrid search where you combine keyword and vector search together just to get more relevant results. And we'll try this out, and we'll have a demo that goes wrong. So we'll see how that goes. I guess everybody recognizes the movie. What is the quote when in the movie when he does that gesture? Yes? Yes, these are not the droids you're looking for. What do you want to have? The water bottle? OK, please hand it over. I don't want to throw it. OK, so let's try this out. You're welcome. Let me make this slightly larger. Is this large enough for everybody to see even in the back? Yeah, good. So we have Star Wars, and I will start very briefly with keyword-based search. And what you do is, so we have a phrase, these are not the droids you're looking for. And you see we have this emphasis tag, the HTML tag for not, and we want to store this. And I will start with keyword search just to give you an idea of like how that works and how that evolves to vector search. So what we do is we'll strip out the HTML because nobody's going to search for that emphasis tag. It doesn't really have much meaning. We'll use the standard tokenizer. So we basically, in Western languages at least, we break up on white spaces and punctuation marks. Asian languages like Japanese and Chinese are a bit more complicated, but we'll stick to simple white space punctuation mark tokenization. Then we lowercase everything, because most of the time when you search in Google, you don't really care about upper and lowercase. You just type in your query. So we never have to worry about lowercasing. So when we store it, we just lowercase everything. When we search it, we lowercase again. We never have to worry about upper and lowercase. We remove the so-called stop words, which are words that are very common and appear almost everywhere, so they carry very little meaning. And we just remove them to reduce kind of like to the relevant content. And then we use a stemmer. Here we're using the snowball stemmer. What stemming does is it reduces a word to the word root. So it cuts off, for example, the ending. Like in English is a very simple language. Like the S at the end is potentially third person singular, or it's like a plural of a noun. You just cut that off because we just care about the concept. So we create this setup. And now I check what would happen if I would store it. And this is, by the way, all still keyword search. So what this does is, these are not the droids you're looking for. We extract 3 tokens only, droid, you, look. You can see that looking was stemmed down to look. And this is basically what is extracted. This is the main difference between a database and a search engine, is that you do all of this work up front to make your search more relevant and faster afterwards. The other things that you have here, we have a start and an end offset. Why could those be relevant? Yes, I think you were first. What do you want to have? The cozy, OK. There you go. So the boundaries are, if you have like the hit in a longer text and you want to highlight where your word is, that you never have to reanalyze the text, but you know exactly where you can set the markers. We also have a position that would be helpful, for example, if you have a phrase search. It is a very weird phrase, but if you search for droid you, we would basically just need to look for documents that have both of these terms. And then one has the position n, and the other one has n+1. So we never have to reanalyze or look at that again. So this is what we extract. And I will store 2 documents. These are not the droids you're looking for, and no, I am your father, which are both pretty iconic here. So if I search for droid, this will do the same analysis. So it will lowercase it. It will stem it. There's nothing to stem here. Will this find something? Yes. So this should find, these are not the droids you're looking for. And it also has like, who says it? So this is keyword search. But for example, if I search for Android or machine or autonomous system or whatever else, we will not find anything. I could manually define synonyms, but that's a lot of work. And I mean, sometimes this can be a good use, but it's generally not what you want to do. That is then where vector search is coming in. And this is where we have Bedrock. So to activate Bedrock, in the AWS console, you look for Bedrock. The 2 things you need to do is, first, in the region, so I picked US West 2. You need to activate 1 or more models that you can run on Bedrock. I just enabled everything here just to be sure, so I can use whatever I want. The second thing you need is you need to create an IAM policy that, and I've been a bit lazy, I just gave it full access to Amazon Bedrock. And then you get the access key and secret out, and with that you can then access the LLM running on Bedrock. And then you can use the LLM either for completion, like asking it questions, or you could ask it to create those vectors out of a text. And we'll do both. Yes, please. Yes, so you have the various LLMs available. So these are all the ones that are available. And then you can actually look at providers and you can say like, I want Amazon Titan. And then it will have examples of how to configure or how to use the different models within Titan. And the same for Anthropic, Cohere, Meta. Was it good enough for Swag? No? OK. We'll find something else. OK, so we have those. And now I want to combine my search with that. So what I do is I have added here the Titan completion. And I'm not running this command. I have run this before, and I've stripped out my credentials. But this is where the credentials would go. And I've just done this right before. So this is the right command. And this is the one for completion. And then I could ask it here, who said these are not the droids you're looking for? And this is interesting because I've run this like 10 times, and I think I've got 8 different answers. And sometimes it knows, and sometimes it doesn't know. So it's not as deterministic as you might want. And now I got an exception. Let's try again. OK, it's thinking. It's very human. Let's see if that result is good. But, well. It's mostly sorry, but doesn't know. If we run it again, sometimes it actually comes back with the right answer. This Titan in that regard seems to be more flexible. But OK, now it seems pretty stuck on not giving me the right answer. And we want to improve that. That is basically the point here. The other thing that you can do is there's text embedding. So I have added this for text embedding, and I'm using the Amazon Titan text embedding. This will basically give you this vector representation of a text. So these are not the droids you're looking for. I will turn into a vector representation. Let me create that. So basically, we just wired this up in the schema here. I will take the 2 documents that we had in the previous index, and I'll just fetch them. So what this looks like is here, we have the text. These are not the droids you're looking for. And then we have this vector representation. And it is a very long array of floating point values. But this represents more or less the document that we have. Yes?
First of all, we have a video. So Bedrock, after the model access base foundation model, we are using open search as a vector DB and then storing everything, both the image plus the embeddings.
Yes, so.
Because you're doing a query here, it means what?
Yes, this is so that's a good point. So the Titan is generating the vector representation here. And I'm storing that. So I work for Elastic, so this is Elasticsearch. This is the original. You don't have these features anywhere else. But that is the. No. Well, comes with is probably a bit too strong. The integration is pretty much the same. Or like, I don't think you have this type of integration there. I think you need to wire that up a bit differently. But that is a bit more in the weeds than I think we'll manage in 25 minutes. What I wanted to show now is, now if I search for robot, now it will find something. Because now, even though, here I'm still using the lexical match, so robot doesn't find anything. But if I say, like, I want to use this vector embedding and search for robot, then I will find these are not the droids you're looking for. The other thing that is kind of interesting here is, by the way, is that every document is somehow related to those vectors. So it's just further away. So just keep that in mind, that if you have a lot of results, you will get good results back first. But every document in the document corpus is basically somehow related, potentially, because like if you have cosine similarity, it's even if it's the opposite of it, it's still some distance, basically. Whereas keyword search will only give you what actually matches. Vector search just gives you what is closest, but basically everything is then close. Or you could, for example, say, if I'm searching for dad, it will give you, no, I am your father will be the first hit. Because we didn't define the synonym here, we got that out of it. And then you could combine that with, like, we search for Android and we search keyword and the vector representation. And of course, the vector representation will be the only one that matches. So we have, these are not the droids you're looking for, is closer for Android than for that, for example, as you would expect. So hopefully this all makes sense and is clear. Now, we haven't really done RAG. We have just done retrieval now. Let's do RAG. So what I have done here, I have connected my LLM. So what that would look like is I could give it a name, and then you would need to provide your credentials again. I have already done that, so I don't need to copy my credentials around in front of you. And then I connect it to my index, and then I can start asking questions here. So basically what I have here is, it's a UI where I can pick the model, and I'll stick to Anthropic Claude 3 Haiku. This is running on Bedrock. Here's the prompt. You're an assistant for question answering tasks. I might tweak that prompt. It also says, like, if you retrieve something, include that citation. And then I can say, like, how do I want to provide that context when asking it? So let's say I haven't configured anything yet. The first one will definitely fail. Let's ask it, who said these are not the droids you're looking for? And most of the time this failed. Let's see how the demo effect goes. Yeah, so here it says the phrase, these are not the droids you're looking for, was said, but no specific speaker was identified. That is because in my context down here, I have said, give me 3 documents. That's probably an overkill. Let's switch it down to 1. And it says, like, the context to provide was the quote itself. But what I want to retrieve is the speaker. So I want to say, like, whoever said that. And then we might say, only answer with the context provided. Hopefully this works out. Let's see. And then if I try again, who said these are not the droids you're looking for? 80% of the times this works out now. Let's see how lucky we are in the demo. OK. Looks good. Was said by Obi-Wan Kenobi. So now with that hint, and by the way, here in the snippet, it also says, like, this was the speaker, this was the context that we have provided here. And now the LLM can just suddenly give us a much better answer. And this is a very made-up example. And maybe another LLM might know this because it has seen this data before. But you can imagine for all types of other data or whatever content you're creating, an LLM will not have seen it or will not know that. Or it might do the famous hallucination. RAG will not replace or stop hallucination totally. It will just reduce it and force it more into the context, especially when you say something like, only answer with the context provided. So much for the demo. I wanted to very briefly touch on 3 other topics. There are many different LLMs. Some are better for some tasks than others. There is no easy answer, especially not that I can give in like 3 minutes or so. You will need to try that out, what works well. For example, we have figured out that for security data, the Claude models for us work very well, whereas for observability data, they work less well. So it really depends on the task you're trying to do and how big the LLM is, on what data it has been trained, what it has been optimized for. You might also have trade-offs like speed and cost. Like, how much do you value the quality versus speed versus cost for your answers? Tuning your prompts is important. We also learned over time that different models need different prompts because they will react differently, and sometimes you just need to give them different context. Finally, RAG is kind of like very structured. It's like retrieval and then generation. But that's not the only place where generation can come in handy. I think GAR is sometimes a term, or maybe you want to make it into GARAG or whatever, and that you have the generation, or the generation augments the retrieval, and the output of that then augments the generation again. So when you store a document, you might add extra context, or you might add better structure. So you actually store more or better information for the retrieval. You can retrieve richer or more well-structured documents, and then the output at the end will be better again. So the generation with an LLM is not necessarily limited to the output, but it can be at the beginning, or it could even rephrase your query. For example, if somebody, let's say we have a recipe search, and you don't know what you're looking for in terms of a recipe, and then you say like, oh, I'm looking for this dish, and it's from Italy, and it's made out of pasta, and it has meat in the sauce, and it has tomatoes. What am I looking for? Because that's very hard to look up. Whereas then it says like, oh, you're looking for spaghetti carbonara, or you're looking for lasagna, or whatever. And then your search has a much easier time just to look up the recipe for lasagna. Whereas the description alone might be hard to map it to the right thing, but that is where the LLM could help you to reformulate your query as well, or make your data clearer. So generation has a spot at all of these. Cool. I skipped this one. The only thing I wanted to pitch is we have a free event on the 1st of October in San Francisco. If anybody wants to learn more about Elastic and Elasticsearch and what we are doing, come join us. We'll have a full day of just sessions like this. With that, or I leave this up if anybody wants to take a picture. We have stickers for everybody. I still have blue light glasses if anybody is into those. Are there any questions? Yes, please. Yes. So Google Search is great for any public data that Google has ingested. If you have your own search engine, you could do it internally or for your private data, and you control exactly what is happening. It might even be that you have information that is confidential, for example, HR data, where you need a bit more security around it, that only HR can access all the data, and not everybody on the team. Yes, you would need to set it up correctly, but you have like stuff that is not public or that needs to be even protected inside, or where you need to structure differently. All of that you could build that yourself. I always struggle a bit to say like you build your own Google, because that's maybe an overstatement, but you can build your own search engine to just power that with your own data. You want some glasses? Sorry? Yeah. Yes? Sure, then I don't have to carry them home, thanks. Pass them on. Oh. Sorry, before I forget, I normally try to take a picture with you so I can prove to my colleagues that I've been working today. Can you all wave? I'm kind of missing you. Cool. Sorry, please go ahead. And I'm out of swag. Yeah, so ideally your model is smart enough to kind of like understand context and then kind of like give it a different representation. So that we're kind of like, so that the vector data store is basically, I don't want to say dumb retrieval, but it's just like you give it this representation and you find something that is similar. How you figure out what is similar and what is related, or what is like just sharing the same name, it's like a homonym, so the opposite of a synonym and stuff like that, that is really up to the model to give you different representation and to figure out from context where stuff is.
That would again lose the, like you mentioned, it has a context window, and just if you have whatever sort of data, like some sort of retrieval mechanism, limit the LLM analytics to that context.
So that is a much deeper topic than we'll manage today. But I mean, normally if you have a very large document, you would do chunking, if you break it up into multiple chunks, you might still have metadata or context that applies to each one of those. So you basically have like some metadata on the overall, and then you have like each individual block can have its own vector representation to tune into that. But that goes much deeper into the model interaction.
I'm just curious. I wanted to ask a question here. How many people are working on projects for their work in Gen AI or RAG or anything like that? Or here? Okay, how many are just here for a school project or their own interest? Okay, I just wanted to get an idea of what the audience is like.
That's the hacker spirit. Any final questions before? Otherwise, I think the swag handout is about to start, so I don't want to hold you. Okay.
We're at time.
Okay. Grab some stickers. Thanks a lot for attending.